Okay, so here's the next question, number 12. A transistor circuit is given below. The Zener diode breakdown voltage is 5.3 volts as shown. Take base to emitter voltage to be 0.6 volts. The value of the current gain beta is dash. So this is not a multiple choice question and we will have to work it out and find the answer. So first let's look at the diagram given to us, the figure given to us, the circuit here. So here we have the Zener diode and here's our transistor. So this would be base, collector and emitter. So let's take the current passing through here as IE, which denotes the emitter current, and the current passing through here as IB. And now I've taken 0.5 milliamps that is passing through here as I2, and the current that is coming through this branch here as I1. Okay, so these are the various aspects that we need to work on. We have to find, in fact. So they asked us to find the current gain. Now in general, we know that the formula for current gain, IE, is equal to 1 plus beta IB. So we need the emitter current and the base current in order to find the current gain. So let's start with VB. This is the base voltage. The base voltage is given to us as 5.3 volts. Okay. And VE, or the emitter voltage is VB minus VBE, or the base to emitter voltage is given to us as 0.6 volts. So that's VBE. VE is equal to VB minus VBE. Okay. So that would be 5.3 minus 0.6, which would be 4.7 volts. So that is VE. The next in line is IE. So let's find the current of the emitter over here. So IE is equal to the voltage VE divided by the resistance that it passes through. So the resistance in this branch is 470. Voltage by resistance, and that gives us 10 milliamps. So we have IE, next we need IB. So in order to find IB, we need to know what I1 is. So we can use this node over here. In order to find IB, we can use KCL at this node. So we know what I2 already is, now we need I1. So I1 is equal to 10 minus 5.3, you know that. The difference between the voltages divided by the resistance in that branch, so that would be 4.7 into 10 power 3 kilo. Be very careful with your units. So that's 4.7 K, and that would be 4.7 into 10 power 3. So if we solve this, we'll get 1 milliamp. So I1 is 1 milli. I2 is 0.5, so we will be able to find out what IB is. Now at this node, we apply KCL, Kirchoff's current law. Now Kirchoff's current law, the incoming currents would be equal to the outgoing currents. So that, let's write that equation down here. I1 is equal to I2 plus IB. Or in other words, IB is equal to I1 minus I2. So I1 minus I2, 1 milli minus 0.5. So IB is 0.5 milliamps. IB is 0.5, we have IE as 10. Now we substitute both into this and find out what our final answer is. Let me just take another sheet of paper here. Okay, so we have IE. IE is equal to 10 milliamps. We have IB, which is 0.5 milliamps. And now we have the formula to find out the gain. IE is equal to 1 plus beta into IB. Let's substitute. That's 0.5 into 10 power minus 3. 1 plus beta into Oh, I'm sorry, I made a mistake here. That's 10. 10 into 10 power minus 3. And here we have 0.5 into 10 power minus 3. So we can remove the extensions of 10 power minus 3 on both sides, and we'll be left with 10 is equal to 1 plus beta into 0.5. And that would be 10 divided by 0.5 is equal to 1 plus beta. And we would have here 20 is equal to 1 plus beta. Therefore, beta is equal to 20 minus 1, 19. Beta is equal to 19. This is your current gain. Let's see if the option, oh right, there are no options here. So our final answer would be 19. I hope this has helped.